we are hiking along this stream, so would like to get the next sample about half a mile from that first point, and then keep going and sample every half mile another 2-3 times, and then that should give us a pretty good idea about water quality in this creek. Okay, we're done 9.33. 9.33. Past the paddock is the tagline. Oh, okay, yeah. When we think about water, the hydrologic cycle, the rainwater gets to the ground and then it takes different routes. Eventually gets to the ocean, and then evaporation comes back to the atmosphere. We call it the incredible journey of water. It's kind of like a story. Whenever we are collecting a water sample, we want to tell this story. Where did it come from? Okay, in its route, what kind of rocks and minerals did this water interacted with?
I did it. I'm a woman in STEM.
Since you have done the leveling, the first one, maybe let's go with this one.
So in hydrology, we use a series of tools. I have 4 in my pack over there that I used for the Silent Lake trip this morning. We use a Dino meter, we use a TDS and conductivity meter, we use a turbidity meter, and we use a pH meter, and a thermometer is built into 3 of those 4. And between those, we get 7 or 8 data points, and from that we can ascertain the water quality index of any water we find.
The hydrology in caves is pretty unique. It's quite different from the surface water hydrology, especially the water table. The whole idea of water table is different in cave. They go up and down at different levels. So we are going to characterize the different levels of the cave based on water chemistry and isotopic makeup of water, basically trying to make sure what kind of connections that we have between the water in the surface, the rainwater, and the deep the lake water that we have in here. So we're going to do chemical analysis and isotopes to see what kind of mixing is going on. A lot of times, very deep cave water can actually rise through vertical shafts and fractures and mix up with water at the upper level.
So in the cave, we're going to set up a lot of drip points. So there are a lot of stalactites and stalagmites. Throughout the cave, we're going to set up bottles underneath each of them. We're going to be collecting 50 milliliter volumes from each of those drip points, and we're going to be collecting 80 milliliter bottles, hopefully a ton, from Silent Lake, from What the Hell Lake, and from Calcite Lake, as well as anywhere else I see water. I was told to collect that water and mark out where it was.
Now the question is, where is this water coming from? Okay, there are a couple of possibilities. One, that this water is primarily coming from the surface, or it could be, some of it could be coming from a deep point. So that's basically what we're going to do, try to explain why this water, what's controlling the water chemistry in What the Hell Lake or Calcite Lake.
Yeah, this is all Highland Creek, and the TDS is right in there. Yeah.
We would like to know the chemistry of the water, and also would like to characterize the water isotopically. Okay, and then we're going to run the results through some mixing models that we should be able to tell what's the primary control
of the chemistry of these water that we are collecting, whether primarily from deep points or mostly from the surface.
The research team has done dye injections in the past. So that hole has been used before and offers a great view of where the Beaver Creek sort of submerges into the rock and joins with the caves. We collected some water driving outside the park upstream of the Beaver Creek. Then the next day we hit up a Highland Creek, going completely off trail, marching through the grass. The buffalo paddocks here on Wind Cave National Park. Once I get back to school, I'm going to start doing ion testing next semester, since Dr. Iqbal has talked me into his Field Techniques in Hydrology lecture.
Basic research helps us to increase the knowledge base, right? We need to know the unknown. The research that we're doing in Wind Cave is not just to get some data for NASA, right? It's the training of us, the faculty, and the students, okay? And this is a lifetime experience, and this is gonna help them to build their career. It's helping us, the faculty, to know what's next, what we should be doing next, not just to get data for them, okay? So there are multi-aspect of the benefits that we're having off of this.